Okay, to graph this equation, which is a pair of hyperbolas, since it's a minus, if it was a plus in the middle it would be an ellipse. Anyway, notice that if y equals 0, there are solutions. In fact, x equals plus or minus 5. But if x is equal to 0, we have no real solutions. Y squared would equal negative 9. So y could equal 3i. But we're only looking for real solutions right now. We want to graph this after all. So there are no real solutions if x is 0. So it's hyperbolas that look like this, a pair where x cannot equal 0. There's no y-intercept, in other words. But there are two x-intercepts, which is when y is 0. So that's the orientation of these hyperbolas. So let's graph them now. To graph this pair of hyperbolas, it's one hyperbola with two branches actually, we first replace the denominators with the numbers the square of something. So this will be 5 squared and 3 squared. The center of this is 0, 0, since it's x minus 0 that's squared and y minus 0. And in order to graph this, we make a box. This box will go a distance of 5 to the right and left of the center. So it'll be out to 5 and to negative 5 on the other side. And the other way we go up 3 and down 3. So let's make this box. Now you draw in the diagonals of this box. These diagonal lines are the guidelines for the graph of your hyperbola. And now we can graph in our hyperbola. The hyperbola asymptotically approaches these diagonal lines and cuts through the x-axis as an x-intercept at 5. Let me bring the x-axis out a little further here. And our hyperbola looks like this. There's that side of it, the positive branch, where an x is positive, and there's also a negative branch here that passes through the x-axis at negative 5. Whoops, let me do this one a little better. So this is asymptotically approaching the diagonal lines. And there's the graph of hyperbola. The hyperbola doesn't include the blue box. The blue box was drawn in the middle there just to help form the guideline diagonals.